Okay, so if you do have a question in this at all, please let me know. But this is solving absolute value. Absolute value, as was said in class, is a distance. The number is from 0. So distance is always positive. That's why we use absolute value in our notes. So take a look at the absolute value equations. The first thing that we have to do, and this is the most important, is get the absolute value by itself. So if you look at that first example, has the absolute value of x minus 5 is equal to negative 2, we have to make sure that the absolute value of x is completely by itself, or even anything that's inside of the absolute value is by itself. Then from there, we set it equal to a positive and to a negative number. Reason being, of course, is because if we're on a number line, we can go into the negatives for distance, but so we're trying to look for those like specific numbers that we would be the distance in between. Kind of think of absolute values almost like the middle, and we're looking for the far right and the far left. Take a look at example number 2 there. If you get down to where absolute value is equal to a negative number before you split it up, there's no solution, because absolute value of any number is always going to be positive, never negative. Take a look at example number 1. Absolute value of x is equal to 2. So for x, we could have two different answers. We could actually have x is equal to 2, or x is equal to negative 2. So if I plug in a negative 2 into where x is, I still get a positive number. Example number 2, absolute value. The question you have to ask yourself first is there anything outside of those little lines, those little absolute value lines? Outside of the equals 2? No. So in this case, from here, I can split it up into 4x plus 6 equals 2, and 4x plus 6 equals negative 2. Now I just have to solve each one individually. So from here, go negative 6, subtract 6, 4x is equal to negative 4, x is equal to negative 1, subtract 6, 4x equals negative 8, x is equal to negative 2. Notice how my answers can be negative. That's fine. Because if I plug them back into my absolute value equation, they'll become a positive number. Whenever we're looking for absolute value, we want to take the absolute value away. We want to make one of our numbers positive and one of them negative. Because if we were to plug those numbers back into any type of absolute value, any negative numbers that we plug in will turn positive, and any positive numbers will stay positive. So it's almost like we're working ourselves backwards from the equation. Did that help a little bit? Yeah, I know it seems kind of weird, but essentially we're kind of like working ourselves backwards in order to find a solution, instead of working with a number and just plugging it in. Take a look at example number 3. Try example number 3 for a second. See what you get. I'll give you some time. Just try it on your own. Take out the absolute value symbols, split it up. Does anyone want to share what they got? I know it's recording. That's okay if you don't want to, but if you do, you can help me out. Okay. Here's what should have happened, hopefully, whenever you did this problem. X minus 3 is equal to 7. And then you would have also set up a similar problem as x minus 3 is equal to negative 7. From here, we're just going to add 3 over to both sides. And we get x is equal to 10. And then over here, we add 3. We get x is equal to negative 4. Now, once again, this is one of the nice things about this unit is if I took those answers and I plugged them into my equation, I should get 7. Check it out. I'm going to write this. I'll write this over here on red. But with the x is equal to 10, absolute value of 10 minus 3 equals 7. 7 is equal to 7. Boom. The x is equal to negative 4. Absolute of negative 4 minus 3 equals 7. Absolute negative 7 is equal to 7. Turns into a positive. Boom. Okay. So the nice feature, like I said, 1.6 and pretty much all of 1.8 for the most part, you can check your answers, which is very, very convenient. Take a look at example number 4. Notice that there's a difference. I just want to point this out here. Notice that there's a difference between this answer and this answer. One of them is positive and one of them is negative. So whenever we have an absolute value that is equal to a negative number, okay, we have the absolute value completely by itself and then it's still equal to a negative number, there's no solution. Because absolute value can never be negative. Okay, getting into a little bit more difficult type of problems. Whenever you have an instance where you have nothing on the outside, or you have something on the outside, you have to move it over first before splitting the absolute value into 2. So for example, in this problem, we've got 5/8 on the outside. That actually has to move over first before you split it. So in this case, you can do 2 steps or 1 step. It's up to you. Most students usually like to multiply each side by 8 first. So then you have 5, absolute value of 5x minus 4 equals 80. And then divide by 5. So absolute value of 5x minus 4 is equal to 16. Or you can just multiply by 8/5, which is a reciprocal. Now that you have that absolute value completely by itself, that's when we can split it into 2 different distinct problems. So 5x minus 4 equals 16, and 5x minus 4 equals negative 16. And notice, it's okay to get fraction answers. It's okay to get whole number answers. It's also okay to get fractional answers as well. Questions at all? Concerns? I'm going to turn the recording off at the end of class too. I'll give you guys some time if you don't want to say anything. I totally get it. Just trying something new. Try example 6 on your own. Very similar to 5. Try example 6. Would anybody like to try and solve? Mia? Good. Good. Nice. So she wrote it both ways. Good deal. Okay, keep going. Okay. Perfect. All right. There you go. Those are the answers. Questions at all? Okay, take a look. We're just going to mix it up again on example number 7. I want to show you this real quick. With 7, we have a -5 on the outside, very similar to whenever we multiplied. We have multiplying or dividing outside of the absolute value. In this case, we want to move the 5 over to start. So we'll get the absolute value of 2x plus 5 equals 16. And then we can break that apart again. Now the absolute value is has nothing outside of it. 2x plus 5 equals 16. 2x plus 5 equals negative 16. For the positive 5, subtract 5 and divide by 2. X is equal to 11 halves. And then subtract 5 here. 2x is equal to negative 21. Divide by 2. And x is equal to negative 21 over 2. You might have problems where you might have multiple things on the outside. For instance, you might have a subtraction and a multiplication. Just make sure that you're doing the addition, subtraction, moving that over, following those order of operations backwards. Questions so far? I'm going to go into just one small little hiccup with these, which are called extraneous solutions that I want to show you. We've got 2 more examples here. An extraneous solution is a solution of an equation. The solution of an equation derived from the original equation that's actually not a solution of the original equation. Essentially, you know how I said that once you get the answers, you can check them to make sure that they work? Well, an extraneous solution is an answer that you get that you plug back in and it doesn't work or it doesn't make sense. Let me show you here with example number 8, and then I'll show you one with example number 9. I think that'll kind of help with that as well. On example number 8, we already have the absolute value by itself. Granted, we do have, x minus 1 on the other side. That's totally fine. So I'm going to split this into 2 and say that I have x is equal to x minus 1. I'm going to say that I have x is equal to negative parenthesis x minus 1. Essentially, we're making everything an opposite sign on that other side. If you take a look at the first one here, if I subtract x to both sides, I get an answer of 0 is equal to negative 1. That's not a solution. And we saw this from Unit 6 whenever we had a number equal to a different number, how we could have something that has no solution. On the flip side, distribute my negative, and I get x is equal to negative x plus 1. I add x over. And a lot of students get confused. When I add two x's, I actually get 2x is equal to 1. Okay, these have imaginary 1s in front of them. So now x is equal to 1/2. So here's the deal. Extraneous solutions. When we plug 1/2 back in, if it doesn't work, it's what we call an extraneous solution. And in this example, that's exactly what happens. We have the absolute value of 1/2 is equal to 1/2 minus 1, or positive 1/2 is equal to negative 1/2. Doesn't work, so 1/2 is what we call an extraneous solution. So we'd still write the solution, we just write extraneous beside it. And literally it takes 2 extra seconds whenever you're doing these problems to just check and see make sure that the answer actually works. Some of you with some of these problems will probably be able to do them in your head pretty quick, just plugging it back in with your eyes and going, okay, that works, or no, that doesn't work. Others, you might just have to write down some work. Yeah. So once I get an answer, in order to check to see if it is like either an answer that is valid for this or if it's an extraneous solution, I want to plug it back into the original equation that I had. So I took and I saw, okay, x here said that it was equal to 1/2. So I just wanted to plug it back into my original equation to make sure that it was valid. Okay, one more example problem that I have for you today. Take a look at example number 9. Here we've got 3x minus 4 in absolute value is equal to negative 4x minus 1. Try it. I'm going to give you a couple minutes. I want you to just try it, see if you can get solutions. When you do, plug them back in. See if any of them are extraneous. You guys want it? Shut that blind. If it's too much. You guys can shut that. Okay, first thing, before we even look at anything in red, look to see what happened in purple. You should have been able to split these up since the absolute value was already by itself. You would have had 3x minus 4 is equal to negative 4x minus 1. Add 4 to both sides, you get 7x minus 4 is equal to negative 1. And then add the 4 over. Your final answer should have been 3 over 7. On the other side of things, if you distribute your negative, you'll end up with x is equal to negative 5. Does anybody have any questions on those steps at all? I mean, if you've gotten that far, you're doing pretty well. Here's where it gets to the check, and this is honestly like one of the easiest ways to do this, is do the side without the absolute value first. Because if you get a negative number on that side, it doesn't work. It would be an extraneous solution. So for example, on this, I have fractions in this first one, which I know a lot of students don't like fractions. Take a look at this. I mean, this side here is going to come out to negative 12 over 7 minus 1. It's going to be a negative number. So it doesn't work. That'll make this an extraneous solution. One that doesn't necessarily want an answer that you get, but you plug it back in and it makes no sense at all. On the other side of things here, I end up with 20 minus 1, which is 19. So since that's positive, I just need to make sure that the absolute value ends up being the same number, which in this case, it's going to be absolute value of negative 15 minus 4, which gives us absolute value of negative 19. So 19 is equal to 19. So negative 5 is a solution. And it's your only solution in this problem. 3 over 7, you don't really have to write in your solution set because it's not a solution. Just knowing that it's what we call extraneous. It's something that you can get as an answer, but then you plug it back in, it doesn't work. So it's actually not one of your answers.